Hey everybody, today's video is going to be about sets and trees, which are two data types, or I guess I can call them data structures. These are objects that appear a lot in both math and computer science, and I'm going to be talking about which one I think best describes reality, which I know is a very broad thing to say. And this video is going to be mainly just me giving my own personal thoughts and opinions, things that I've been thinking for a while about these two data types. So real quickly, I'm just going to define what it actually means to be a set or a tree. So a set is essentially just going to be a collection of objects. So for an example, the set of numbers might be something like a set with 1, 2, 3, etc., etc. You know, we can think of the set as the set of animals. You know, the set of animals is going to have a cat, it's going to have a dog, and so on and so on. Could do anything, set of colors, anything like that. Essentially, a set describes a collection of things. These are collections. I'm going to write that here. Collections. Now, a tree is a kind of graph shape. Not a graph like a y equals x squared graph, but a graph as in a collection of vertices and edges. And a tree is one specific kind of this, where we have a thing at the top, and that relates to some things below, and then those relate to things below them. And maybe this has some more, and it can go down as deep as you want, right? Now, a tree, I think, is better described not as a set of collections, but a set of relations. You could think of trees in a lot of different ways. One way that you could think about trees is like something like a family tree. So, you know, you could have parents with children and then their children and their grandchildren, whatever. You could have, you know, an org chart. This is like a company, describing the roles in a company. That's kind of like a tree. But typically when you're deciding whether you want to express something as a set or a tree, you sort of have to think about which of these two factors you care more about. You care about what something has or what something is, or how it relates to other things. So I'm going to start by talking about people, or like, you know, a social framework. How do we see like humans? If we imagine humans, are they a set or a tree? You know, if I consider a bunch of people, right? I've got the set of all people. Is this a reasonable way to think? We've got Mary, we've got Mark then, and we've got you know, I don't know, Jane. All the people, set of people. Or do I want to represent them as a tree? Well, if I want to represent them as a tree, then these lines have to mean something, right? And if I want to represent them as a set, they all need to be kind of broadly equal to each other. I think that when you think of things, you're naturally going to consider them one of two ways. And my theory about this is that your political persuasion might actually impact the way you see the world and the way you see other things in the world. A set in this context feels like a very egalitarian structure. We're sort of saying that we're all the same, everything's part of the same meta category or category of people. You know, in this set structure, Mark and Jane are equal to each other. Whereas if I represent them as a tree, you know, well, it feels a bit more classist, or maybe a bit more hierarchical. We're going to have people above other people. This is how it works sort of already under like capitalism, or specifically in companies under capitalism. But they're two broad ways that you can think of people. This might be a more left-wing idea, I suppose, because it is more egalitarian. Yeah, flat structure. This here is a tall structure with people above other people. Now, another question is regarding numbers. Do we think of numbers fundamentally as sets or trees? Well, there's a really big part of mathematics, and it's called axiomatic set theory. And I'm not going to go into what it is. I hardly understand it myself. But the idea is that numbers are best thought of as sets. If you think of numbers as sets, and you apply some axioms, which are statements about math that are self-evidently true, or that we don't prove, then from that framework, you can form almost every mathematical statement. And I'll do a separate video about this because it's a really interesting topic. There are different ways that we can think of numbers as sets. So for example, a guy called Zermelo, he had a theory about numbers as sets where he said, well, 0 can be represented as an empty set. This symbol means empty set, but this is the same thing as just saying like something with nothing in it. It sort of makes sense that that would be 0. And then 1 is the thing with 0 inside of it. So it's the set that contains the empty set. And then 2 is the set with the 1 inside of it. So it's the set that contains the empty set. And in general, set n is just going to have like n open brackets, and then the empty set, and then n closing brackets. Every number contains the number before it. And I won't get into why he thought this because it's really complicated. Von Neumann, who's another very famous mathematician and computer scientist, said that he agrees that 0 should be most aptly represented as an empty set, and that 1 should then be the set of 0, which, you know, again, is a set with the empty set. But then that every number after that, 2 should be represented as 0 and then 1. So this would be like an empty set and then a set with an empty set. 3 would then be a set of 0, 1, and 2. So it would be the empty set, and then the set with the empty set, and then the set with the empty set, and the set with the empty set. One utility of thinking about it this way is that the number of things in the set, or elements in the set I should say, actually tell you what number the set represents. So the set 0 has a length of 0. The set 1 has a length of 1, set 2 has a length of 2, etc. One interesting thing is that if we refer to these numbers self-referentially, as in a number comes from the number before it, right? So I'm defining my numbers n, kind of like by saying it's n minus 1 plus 1, right? I can create numbers this way, and then all I need is my base number is 0, which is my empty set. It kind of feels like we're kind of doing a tree structure as well, you know, or maybe way up with 0 at the top, 0 leads to 1, leads to 2, leads to 3. This isn't a very exciting tree structure because it's one dimensional, right? There's no branching out. And I suppose a tree, you kind of want to have branches. Otherwise it kind of isn't a tree. I think part of the point of a tree is that these elements could have more than one child. So how can we express numbers as trees? Is it reasonable to think about it that way? Something I've talked about a lot on this channel is prime factorizations. I think I did a big video about those. Numbers will have a unique set of prime factors. So I could represent numbers that way. I could say 60 is 2 times 15, which is equal to 3 times 5. And these are prime numbers, so I can't break them down any further. And so this is sort of this tree that represents 60. This is another interesting way that we can represent numbers, because every number is going to have a unique tree. And these things here, which are called leaf nodes, the bottom of the bottommost points on the tree, are all going to have to be prime numbers. So yeah, you can represent numbers either way as well. What I'm kind of getting at is that I think most things in life you can represent as either sets or trees, and both are kind of equally valid. But I'm going to move on to the next example. So the next example, and I think a very interesting example, is, you know, the world. This is more of a philosophical question. All things in the universe, are they fundamentally sets or trees? Are they objects that just have properties and we can list the properties like a set? So I don't know. I have a chair, and the chair has certain properties. It has a shape, it has a weight, it has a size, it has a color. And could I say, like, you know, I have an object called a chair, and I can, in a really fundamental way, just represent that as a list of properties. And that actually describes my chair. Or I could think of a chair as an object that's built from smaller objects. And that will lend itself more to a tree way of thinking, right? If my thing at the very top of my hierarchy is a chair. Well, a chair is made up of certain things like legs and a base and a backboard. And then I could speak more about what these things are made of and go down forever. Or, if I can't go down forever, I have to stop. And if I have to stop, that implies that there's going to be some item at the bottom of this hierarchy that has no smaller items that it's made from. A long time ago, humans would suggest that these things are atoms, each individual atom. But we even know now that we can split atoms, but that's been shown now, so we'll go even deeper. And that might get into some weird quantum stuff. Now, another way that we can think about trees is with values. So, moral values, I think, are best represented as a tree, not as a set. Because moral values are these things that are really they feel really integral to our lives, that I think that are inherited from higher values. If someone says something like murder is wrong, this is a value statement, right? They're saying that something is incorrect. And if you ask that person why, they're going to say something like, I don't know, it takes a life. It takes life. And then you might ask, why is that wrong? Right? Why? It takes life. And you might again ask, why is that bad? Why is that bad? Say something like, life is good. Right? Life is a good thing. So we don't want to lose good things. Notice that at every step, they're all still value statements, right? We're not getting into any descriptive claims about the world. These are all still asserting some moral premise. And I suppose I would argue that if you keep asking why, they're going to always have to be sort of these ought claims where we're making a moral statement, right? Life is good is still a moral statement. It's kind of a sneaky one, but the word good is still like a moral word, right? In a purely, scientific, materialistic worldview, I don't know if we have room for words like good. So that begs a really reasonable question, which is, what is going to be at the bottom? What is the base value? So if we consider values as a hierarchy, right, and we say something like, these here are moral values we have, and these are the reasons for them, or the value that they stem from. These are the values that those stem from. And if you keep going up the hierarchy, there's going to be something at the top, and that thing is going to be your most fundamental value. So you might ask, well, what is that value? That's a really interesting question. And some people, this is a Jordan Peterson idea, if anyone's into Jordan Peterson, I'm not really into him, but I've heard him say things like this before. We'll say that this thing is God, or one of the best ways that we can think of God. Not only is God the most fundamental value, but it's the thing that gives us the most fundamental value. This is a really, I think, strange and trivial definition for God, because it is more of a definition than a description. If you define this thing as God, I don't think you've really done anything interesting, because you can define anything as God. You have to sort of defend why this thing ought to be called God, or ought to be thought of as God. Now, you can make a very similar argument about factual values or claims. And again, you're going to have to be that annoying 5-year-old who keeps asking why to something. Any claim like, it is raining. It is raining. A kid's going to ask, why is it raining? Because kids are curious. Why? And then they're going to say something about the precipitation, or the density of the clouds, something like this. The kid's going to ask why. You might then say something about physics or a fundamental physical rule, something that makes these things happen. The kid's going to ask, why does that rule exist? And eventually you're going to get frustrated with the child, but you're also going to end up having to say either, I don't know, or because I said so. or it's true for no reason at all. Those are the two options, right? If these are all going to be different statements, either you're not going to know why you think it, or it's true for no reason. And both of these are very unsatisfying. If the second is true, at the very bottom of this Y chain, the adult says it's true for no reason. This is really scary, because it implies the existence of truths that we don't know are true, or that we don't know why they're true. And then, the question becomes, why did you pick those ones? If it's a true for no reason, why do you believe it? There's a whole conversation to be had about axioms and how we pick our axioms, and if it's even reasonable to have a heuristic to pick an axiom, because that heuristic is going to inherently presuppose the axiom itself. So maybe that heuristic should become the axiom. If they say, I don't know, that implies that there might be a reason, you just don't know it. And that's fine. And if that happens, this chain, in theory, could go on forever. But you can make a similar argument hierarchically that facts all come from other facts. Which means that if this chain has an end, at the very top we have something called a meta fact, or a base fact, or the most true thing, or the thing that gives us all the other truths. This is another cool way of thinking about God. Keep in mind also that with these hierarchies, the direction of the relationship doesn't matter as much. You could as easily argue that another way of looking at it would be, this is your claim, so at the very top is your claim you've made, claim P, and then from here are your reasons. This is reason 1, reason 2, this is reason 1 for reason 1, reason 2 for reason 1, these are the reasons for this one, and then they keep going. And then the question is, when you hit the node with no children, what does that say about the node? Well, it says that node has no reason. And so these are going to be your self-evident truths. I don't think you can just describe an object as a set of atoms. I think an object is more than just a set of atoms. I think we need to define things by how they relate to other things. It's also true of, which is why I'm sort of team tree here, I suppose. It's also true of language. There's a really interesting conversation to be had about what definitions actually are. Because if you look up the definition for a word in the Oxford Dictionary, it's going to tell you a definition. But that definition is going to need to have other words, right? And so you might not know what all those words mean. You look up those words, and that's going to give you a definition that's going to involve other words. So what we end up having is we have a big space of words, and this space goes on for as many words as there are. And let's say that if a word requires another word in its definition, we point to it. So for example, if I ask what a car is, it's going to be hard to define the word car without the word wheel. Let's just assume that the word wheel is required pre-knowledge to define what a car is. So car can point to wheel here, right? Let's say to describe a wheel, you need to describe a tire. This points to this. If I take every word possible, so everything represents a word, and everything points to words that are required by their definitions, two things can happen. Either everything is ultimately circular, meaning that all words are defined by other words. Like I could have a chain of 5 words that all point to the right. And if this happens, it's quite scary, because it's like, well, what do any of these things mean if they all refer to each other? That's one possibility. And another possibility is that all of the words in this network all point to the same sort of fundamental words. And so those are the only words that we need to take as an axiom, or as a matter of faith. In a sense, we have to pretend those words have meanings, because if we don't, we can't derive meanings for all the other words. Again, this is going to be a tree structure. Anyway, I think that's all I have to say about this topic. I might do another video about it. But yeah, thanks for watching. Cheers, guys.